Now we're going to talk about a topic that I've moved forward from week 8, which we're labeling as 7.6, which is on the SDLC design topic. You could kind of argue it's coding. I mean, design is this really broad category where, it's like everything from requirements to like language specific stuff, right? So you could argue this might fall in the development category, but we're trying to make you think about like what is well-designed software irrespective of what language you use, and chairs chairs reclining, and this is the second part of an SE Principles lecture that is focused on two main topics, which is decorators and single responsibility principle, but largely it's mostly just about decorators. And decorators are a really powerful concept that exists in a number of languages, particularly scripting languages. And they allow us to add functionality to a function without altering it, right? So sometimes you might have referred to these types of behaviors as wrappers. Like, okay, I've got a function, now I'm going to make a wrapper for that function to wrap some functionality around it. Formally, we refer to that as decorating a function. But before we get into how to do that with Python, we're going to talk about... Before we get into that, we're going to talk about like a few key and important things about like functions in Python, to just like make sure you've solidified your understanding. So first thing, and this is a fairly complex topic. Where is it? Week content, lecture code. I think I put it in week 8. Yep. Okay. So I'll have to move this to week 7 because we're doing this one earlier this term. Yeah, let's have a look at this. So we've got these like 7 decor files, which are for decorators. And let me just shrink my terminal down and we can have a look at this. So I don't really know why it's the case, but if you just type cd when you log into VLAN, it gets rid of all that really long, lengthy, annoying path. Like you can see how this one doesn't have all that temp AMD ravel stuff. So I've got all these files. So the first one we're going to look at is decor1, right? And decor1 is a fairly straightforward file. We have 2 functions called foo1 and foo2. They both just print out a ZID, name, age, and suburb. And except obviously foo2 has some some other relevant things here. And then we have a main function that, calls foo1 with like ZID, name, age, suburb. We have foo2, we have foo2, foo2, foo2. And the main point of this slide in particular is to talk about positional and non-positional arguments in Python. So you'll hear these like words thrown, or keyword arguments, sorry. I always get these ones confused. So there are 2 kind of key types of arguments that you deal with in Python, which is positional arguments and then keyword arguments. And you can see positional arguments are called by their position in a function parameter list, and keyword arguments are defined by their name. So a standard function, like a C-style function, a Java-style function, these ones you're probably used to, they're all positional arguments, positional parameters. Something, however, like Python offers the second capability, which we'll talk about in a sec. So firstly, on the foo1 category, you can pass in 4 strings and it will run for you, right? Like if I comment this out, this will behave exactly like you expect. Python 3 decor1.py, right? It'll print those 4 things out. One thing that you can do in many languages is you can provide default parameters or default arguments. And what I mean by that is if, for instance, if we call foo1 but we don't pass in a suburb, we can give foo1 a default parameter, right? We can say that the default suburb is just going to be Sydney. So that when I call this without the 4th argument, it just prints out Sydney, right? And that's very powerful. We can also have a default age as well, a default age of 22. So that if I call this without an age, it will also now print out an age, like that. So very powerful stuff. And the way that default arguments work is that your default arguments always have to start on the right and work their way to the left. You can't really... some languages you can, but like it's very hard to kind of have default arguments and then non-default arguments and then default arguments, because generally when you fill out a function, you can see here non-default argument follows default argument. That makes a lot of sense, right? So name is a non-default argument that follows a default argument. So the general rule with function definitions is once you start giving arguments or parameters default values, everything after that in the function definition has to have default values too. Just to be clear too on terminology, so in function definitions we refer to these things like ZID, name, age, and suburb as parameters. They're function parameters. And when we make function calls, which is the invocation of a function, we refer to these as arguments. So these are parameters up here and these are arguments. Those two words are often used interchangeably, but understanding the difference between the two can really help with your communication on the topic. So that's how we do like foo1. Now in the case of foo2, you can see that all of these are default. So we can actually do something like call foo2 without any arguments. Because they're all default, we'll just get a whole bunch of nuns, right? Nuns, that's funny. Yeah, none. Now, a lot of languages like this. One thing that makes Python a little bit unique is that when in Python, you are able to actually, when you make a function call and provide it with arguments, is actually give those arguments specific names and associations. So what I mean by this is that when we do something like, say, foo2, all these things, what we're really saying here is that we want the ZID to be that, we want the name to be this, we want the age to be this, and we want the suburb to be this. Now, in reality, this goes a little bit against your more fundamental teaching of functions, which is the idea that the names of the parameters don't have any bearing on how you call it, right? Because the names of the parameters are in a little black box inside the function. Now that is true by default, but the point is you can break that to actually use them here. So this line here on line 13 is valid Python. This will work because you're assigning particular values to particular arguments. And this is where we call these keyword arguments, because we're not assigning a value to a parameter based on the position, we're assigning it based on the keyword, right? So something like these three lines here are all about positional arguments, because it's the position. If we swap these around, if we swap Kensington and 72 around, it's going to change what arguments they're representing because the position's changed. But for something like this, watch what happens if I move age here to the start. If I move age to the start and I call this again, it still says 341, Hayden, 72, Kensington, even though I have changed the way I pass those in, because now they're keyword arguments. So their position doesn't matter, but their keyword matters. And they're two very different ways of passing things into Python arguments. And you can mix and match these approaches too. Like you can actually you can start with positional and finish with keyword if you want. You can't start with keyword and finish with positional. So what I mean by that is I can actually give like Z3418003 Hayden, and then I can say, you know what, and the suburb is Kensington and the age is 72. So the first two will be positional, and then the next ones will be keyword, and this will work as well. Now what I can't do though is like do this where I kind of go positional keyword, positional keyword. I'll get a similar kind of thing because Python is just looking at that and it's like, what do you want me to do with this argument? Where do you want me to put this? I have no idea. This is really confusing. So yeah. That's the main part of that example there. Very powerful stuff. It can make your code a lot more readable. Python is not a typed language, which is not great because it can make it really hard to understand what's happening. But the use of keyword arguments can actually help quite a lot, right? Because you can see more clearly like what these values are relating to in terms of arguments. Now that's the first example. The second example is when we get into a very strange and curious part of Python, which relies on the knowledge we've just learned, which is dealing with args and quarks, right? And I know that sounds like some, random nerdy thing, but basically, in any given function, after you define your parameters, whether they're default parameters or non-default parameters, you can, at the end of your function parameters, put two special things there, which is star args and star quarks. And what star args means is the positional arguments. They're the main arguments passed in. And star quarks refers to the keyword arguments. So what this is like is, this is like when you... this will capture all of the remaining variables that aren't defined. So what I mean by this is, like, let's do a simple example here. If I call foo and I pass in a ZID of my ZID and my name, like this. This will just print out, and let's get rid of these for a sec too. This will just print out normally, Python 3 decor 2, like that. 3418003 Hayden, great. If I don't have Hayden there, it prints out none. If I have Hayden there, but I maybe swap these around and I pass them in as keyword arguments instead of positional arguments, then I'm going to get this. I'm still going to get it correct because keyword arguments are position independent. But what happens if I pass in something else, like the planet Jupiter? Nothing. Because these extra arguments, whether they're keyword arguments or whether they're positional arguments, you can pass in more arguments than a function. Well, you can't really, you can't do that. Like, I forgot to get rid of this. Watch what happens when I try and do this, right? It's like Python complains. It's like, sorry, but you passed in a keyword argument size that I'm not ready for. And if you didn't pass in the keyword argument size, you get another one, which is like, sorry, but foo has 0 to 2 positional arguments, but you gave me 3. ZID, Hayden, Jupiter. And one way we can get around that is, rather than have to define every single possible parameter that we want to take in explicitly with a name, we can actually describe things in terms of, just capture everything that's given to us. Make it super open-ended. And we do that with args and quarks. So if you put star args and star quarks in your parameter list, then you essentially make your function able to be called with any extra parameters of any scope, right? So I could add here Jupiter is this and size equals 8. Now what these two args and quarks parameters are is args is basically a list of all of the leftover positional arguments, and it stores it as a list. And quarks is a collection of all of the extra keyword arguments stored as a dictionary. And that makes sense, right? Because positional arguments are just values that you'd store in a list, whereas quarks is a list of keyword arguments that have a name and a value. So it's basically a dictionary, like a series of name-value pairs. So if I print out args and quarks, I don't need the star or anything when I print it. I get this. It's actually a tuple. I don't know. I shouldn't say list. It's technically a tuple, which makes sense, right? Because you want them to be read-only. So I have my tuple here. Jupiter, size 8. Perfect. This makes sense. So I can actually capture all these things. And this is really useful because if you want to capture like more stuff, all of this, it just keeps getting put into this quarks dictionary. And if I have more positional arguments, like this, it gets put into this quarks dictionary. Right, so it's basically just an alternative way of passing in list or dictionary structures, except instead of doing it by passing it through some variable, you're actually passing it through the parameter list. You might think, oh, well, when is this ever going to be useful for me? Well, an example could be writing a printf function, right? I could write a printf function that takes in a format string, and a series of args, right? Like, let's think about the C style thing. And I mean, let's try and do this. So let's just print out format string and args. Now let's try calling it. So I'll get rid of that for a second, and I'll say, printf %d, 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 and I'm going to give it number 1, 2, and 3 like that. Okay? Well, when we run this, what we're going to get is we capture the format string, and then the rest of the arguments we capture here. So let's imagine this only works for integers. Well, we could write a printf really quickly, probably. I mean, let's Google Python string replace. What do we get here? Replace the word bananas. I only want it to do it on one of the values. Count a number specifying how many occurrences of the old value you want to replace. Perfect. So what I want to do here is I basically want to say format string dot replace, and I want to replace %d with args 0, right? Args is a list. It's a list of numbers. So I could try this out and replace each %d with args 0, args 1, and args 2, and I need to give it a count of 1. Because if I give it no count, then what will happen is Python will replace all the instances of %d with one of those values, but I only want it to do one at a time. So now we can try this out. Let's see this. Let's do this. Format string replace argument 2 must be a string, not an int. Fair enough. Have to convert these to a string. %d, %d, %d. That's not good. That's not what I wanted. And I think this is because replace doesn't do things in place, right? I think it returns something. Yeah, so I'm not actually doing anything with the return value here. So I would need to like do this basically. Let's try that. 1, 2, 3. Okay, well this kind of works, but now let's see if we can do it with a for loop to make it more general. So for arg in args, format string equals format string dot replace arg %d. And then we'll just print format string. And maybe we've just written printf. Let's try this out. Hi, my age is %d and my fave numbers are %d, %d, %d. You know, 18, 1, 2, 3, 4. So let's try that. And this should work. Oop, sort of. Nearly worked. What's gone wrong here? I forgot the 1 again. So this is why we needed to look up the docs, because without the 1 it replaces all the %ds with 18, and then we never get to replace the others. Yep, my age is 18 and my favorite numbers are 1, 2, 3, 4. So very powerful stuff, right? Like think about that. That took us 2 or 3 minutes to write a printf using the *args parameter. And you could use quarks or args for a whole range of different reasons. So that's our decorator 3 example. If we have a decorator 2, if we have a look at our decorator 3 example, you can then write functions that don't even have any genuine parameters. They just have args and quarks. This is like a truly dynamic function where it will literally just, you could give it anything and it will just print it out. So if I run deco 3, it doesn't matter. If I give it this, then I get, okay, well args is a list of 2 items or a tuple of 2 items, and then quarks is a dictionary of 1 item. If I give it just numbers, it's going to be args with 5 numbers in a tuple. Super dynamic. So then you might be thinking, what's the whole point of this? Like, what's the whole point of like going to all this effort here to have all these like super dynamic functions? And we're going to get to that, but first we need to talk about decorators. So what exactly is a decorator? Well, we said it's a wrapper for a function that adds functionality to it without altering the function itself. Right? And a really simple example of that is if I have a function called getFirstName that returns my first name, and I have a function called getLastName which returns my last name. If I'd like to create functions that basically are like uppercase versions of that, rather than modify my getFirstName function or my getLastName function, I can actually just wrap a function in another function, right? So I say, you know what, I'm going to have a make uppercase function that basically takes in a string and makes it uppercase. So if I want to have an uppercase getFirstName, I can just make uppercase getFirstName like this. Now this is, again, we just call this a function wrapper. It's probably something a bunch of you use that terminology. There's probably another bunch of you that don't really think, like you haven't really thought about that before in terms of words, but you are comfortable with the idea. So get first name, get last name, sweet. Like that should make sense. It behaves for us as we expect. Screaming my name. So that's a very crude demonstration of a decorator. But what is a proper decorator? And this is what we're going to look at now. This is where things really start to matter. So if I have a function like getFirstName that I want to permanently add functionality to, right, without ever having to change the code of that function, then I can use a decorator. And you've probably seen these because you've worked with Flask, right? Because this is what Flask does. And the way it works is a little bit complicated. And in fact, I could probably get rid of these for now. Just to keep the demo simpler at the start. Deco5. Yep. So the way this works, the way decorators work is when you put at and then a function above another function, you are decorating it. And what that means is that when someone calls getLastName, what they actually get is the make uppercase function that's been given this getLastName function. Now I'll be very upfront with you about this. This stuff is confusing, and there's going to be a handful of you watching this who are not going to understand it on the first go. You might have to watch it a second time. There's going to be a bunch of people that don't understand it till you use it and poke around with it. And that's totally okay because it's a little bit confusing. So let's have a look here. I'll actually keep this simpler. Let's just start with one example. GetFirstName. When I call getFirstName, what actually happens is I call the decorator. I'm calling make uppercase. And make uppercase is a function that is given getFirstName. Right? So when I call getFirstName, I'm actually calling make uppercase. What make uppercase is doing is taking in the function getFirstName, and it's returning me another function. This gets a little bit meta programming-y, but you know, and sometimes you can refer to these a whole bunch of different ways, but make uppercase is a function that returns a function. And the function it returns is the wrapper function. And that wrapper function is a function that literally just returns the result of getFirstName made uppercase. Right? It's very confusing. But make uppercase's job is to return a new function. And like what I mean by this is that maybe I'll give you an analogous example here. If I just call make uppercase, and all make uppercase does is return functions, then what make uppercase is it's a function that returns a function, but the function it returns is unmodified, right? What is this function input here? Well, this is the getFirstName. So when I call getFirstName, the decorator gets in between us. It says, give me a sec, I need to modify getFirstName. So you call make uppercase, you give it the getFirstName function, and you return the getFirstName function, unmodified. So getFirstName does exactly what it was going to do before. Okay, sure. That makes sense. That's why we get this Hayden response that's just all lowercase. Well, mostly lowercase. But what happens if you want to return a function that gives you the result of getFirstName, but does so after making it uppercase? Well, with make uppercase here, remember this returns a function. So if we want to create a function, right, like I could create a function here called pointless function, and all this pointless function does is it returns the output of function, and I could then return pointless function, like this. So now what I've done is I basically added useless code here. This does nothing different, right, because we know that our decorator returns a function, not a value, it returns a function to use. Previously, we just returned the getFirstName function. That's what we had when we just had like return function here. But what we're going to have now is say, you know what? I want you to return a new function called pointless function. And I'm going to define pointless function as something that literally just calls the underlying function getFirstName and gives you the value. Right? So again, this is what I would call a pointless wrap here. Because you're wrapping a function for no reason. Like, I'm literally just saying, I'm going to make another function that just calls this other function and returns you the value. The reason, though, that we like to do this is because this allows us to do some funky things, like say, you know what? My pointless function is actually going to return the value of the underlying function getFirstName, but not before it makes it uppercase. And now we have a decorator that can make anything we want uppercase. Now to give you another example, let's make another function called double string. And this is another decorator. And I will use this decorator here instead, double string. And what double string will do is it will take in my getFirstName function. It will generate a new pointless function. Oh, it's not called pointless function so much anymore. I'll call it wrapper like I was used to. It'll create a new wrapper function that returns the call of my function uppercase. But in this case, I don't want it to be uppercase. What do I want to do? I want to double the string. So I'm going to have it return the call of my function twice. Or more specifically, maybe times 2 here. So it does Hayden. Now again, you might be thinking, okay, well, like how does this work? Well, again, when we call getFirstName, because it has a decorator, before Python executes this function, it gets decorated. It gets decorated by the double string decorator. And the double string decorator takes in a function getFirstName. It creates a wrapper function that's whole job is to call getFirstName twice, like return the value of that times 2, and then return wrapper. So that's all its job is, so it decorates it. Are there any questions so far? Because this is a bit of a confusing topic, and if you have questions, now's a good time to ask. Cool. Okay, seems good to you. Great. Now this is actually most of the next couple of examples, because the next couple of examples I just like take this a little bit further. That's okay. Patrick says, so it's like adding an attachment to your already made function. It's about wrapping it in a behavior. So you have a function that does something, but you want to take that result of that function and do more with it. In the first case, we wanted to make it uppercase. In the second case, we wanted to double it. So, yeah. Now, the last complicated part here, genuinely, is how do you play around with parameters and arguments with this? Because this is a very static thing that we've looked at here, where we're like, you know, our function doesn't have any parameters, our decorator doesn't have any parameters, but in the real world you often do have parameters, right? Like you've got a Flask server, like that's what this is. This is a decorator that literally takes your function and does more with it. But you can see it has an argument that's being passed in here. So a couple of things here. Firstly, if my getFirstName function takes in a prefix, right? Like let's say it takes in a prefix. Okay, now if this isn't decorated, this makes sense. The prefix might just be like doctor. Yes. Excellent. So you do something like this where like this makes sense. You give it a prefix and then it comes out like this. Cool. Now what happens when you put the decorator there? When I put the double string decorator there, when I want to double the string. Okay, well this isn't going to work now because remember, this argument is now passed to the decorator. This is the confusing part, right? Like, because the decorator doesn't just like decorate the function over here and do something. It literally wraps around it. It's like a layer of abstraction that you have to go through. So when you call getFirstName now, you actually have to go through the double string function. But what you notice is the double string function takes in a function. So you think, okay, well, maybe it needs to take in a prefix too. And then you're like, maybe I'll pass in a prefix here. And you could try it and it won't work. Something strange will be happening. And that's because you have to stop and you have to think about, like, what is happening here? What is happening here is that when you call getFirstName, which calls the double string decorator, before you ever get back to the main function, the double string decorator takes getFirstName and it does something with it, and it gives you back a new function to call. So this def wrapper is actually what is called in the end, right? Because that's what you return. Your decorator is a function that gives you the new function. So def wrapper is actually what's called. So if I wanted to, I would have to put the prefix here, like this, right? Because again, you just think about it. Previously, function getFirstName was the function, but when we wrapped it in a wrapper, we removed the parameters. And if we want those parameters to be passed through, then we need to actually be more explicit about that, like this, right? Great, that makes sense. And this is how we get examples. Yeah, sure. And this is why you saw those original args and quarks in the early ones, because what you often want to do with a wrapper is you don't actually want to like explicitly put all these parameters here, because what this means is that our decorator now is a little bit overfitted to this particular example. So what I mean by that is if I have a getLastName function that doesn't have a prefix, it just actually returns the last name, like this, and I call print getFirstName plus getLastName, like this, right? And they're both decorated, so they're both going to be doubled. And I call this again, we get an error because now the decorator wrap is expecting the prefix function, but my last name doesn't have a prefix to pass in. So this is where args and quarks becomes really handy, because how do we pass that in again? I always forget. Yeah, okay. Because now what this is saying is the wrapper is just going to take in anything it's given and pass it through to the underlying function. So making it super general, like that. So now this will work with like 1 argument, 2 argument, 5 arguments. Prefix is not a function, it's just a string. It's like doctor that we passed in here. So generally when it comes to decorators, when you're creating these wrapper functions, which is part of every decorator, you want to you want to pass anything in. You don't want this to get in the way, you know what I mean? You like want it to be a truly like pass-through process where it's like, I don't care what you take, I'm not looking, I'm not bothered, just I'll give you everything I'm given, right? The perfect messenger. Yeah. But you can do tons of things with decorators. They're very powerful. That's why things like Flask use them, for instance. And yeah, we kind of did this example, the double repeat thing. And this one gets a little bit more lengthy, but I don't think this is a particularly exciting example. Now, here's the big question though. Where do you use this? Well, you can use this a lot. Decorators are super powerful, and I'm sure you could find a ton of places. In fact, you know, your fixtures and PyTest are kind of like decorators in a way. They're a way of trying to abstract out common logic. They're not decorators, but they might solve a similar problem for you where you want to abstract common logic into something more general. But I will give you a hint, which is probably like one of the easiest ways to get marks for iteration 2 or 3, really. You could apply this to iteration 2 if you wanted to. If you're looking for like good design marks, is think about all of the functions that only work if the token is valid. Right? Really simple stuff. So you've got most of your functions only work if a token is valid. So I'm sure most of you, what you all have is that in the first couple lines of all of your channels invite, channels create, channel invite, channels create, message send, you've got some kind of line that like says, you know, like a function that's like fail if invalid token, or like if not check token then throw exception or something, right? Like you've got some kind of repeated code inside the body of all of your functions. Whereas one thing that's much better from a design perspective is keeping your functions focused on the logic that they're trying to solve, and instead using decorators, for instance, to replace that logic, so that you decorate all of the authorized functions with some kind of decorator that says only valid authorized user or something like that. You can definitely use it in other places, but I think that's the easiest like way that's like, okay, sure, that makes sense. And that's most of decorators. Really cool stuff. Most languages have them. Some stupid languages like Java don't have them and make you implement these design patterns, but a lot of languages have decorators of some form. This last topic, we'll finish early, but this last topic is not really... it's not really like a big coding piece because it's pretty straightforward. We're more just like explaining to you this is a real thing, which is that a concept called the single responsibility principle, which is something that you could come back to and talk about with your tutor or in anything really, is just that every module, function, class, particularly function in your context, should only ever do one thing, right? They should only ever focus on one thing. So whenever you're writing a piece of code, a great way to improve the style, design, code quality is to actually look at functions and say, is this doing one thing, right? Like a function should have a name, that name should denote one thing that it does, and if it does more than one thing, it should be broken up into smaller functions. Either literally broken up or like it itself calls many smaller functions. So yeah, it's generally a good idea, breaking code up into functions. Like we've been learning about this since your second week of education in this field. And it helps a lot with readability and modularity, makes things not break. It's generally a good principle. The only time you have to be considerate of it is there is a fine line where breaking things up too much can be more confusing, but we'll leave that judgment to you. And I'll just quickly show you some files. We won't go through them too extensively. Oh, where'd it go? Oh no, it's missing. But that's okay. I mean, no. Not sure. But the general gist, like the example that I wrote for this originally was something like, if you remember, we did this like a GPS example a while back where, I'm trying to remember what was the example we did where we were like calculating distances or something? Was it week 4? Week 3? It was when we were talking about top-down design. Maybe I don't have it here, but it's like, it's the one where we were like, okay, you want to calculate the time it takes to get to two places, right? So like, if you have a function, for instance, that's like def, get distance and time, right? And this function basically returns like, it returns a tuple of like the distance and the time after it like does stuff. In general, like you should really just take some time to go back through all your functions in your code, say, all right, are these functions trying to do many things? Are they trying to like authorize my user and return the user ID, for instance? Or, I mean, maybe that's not the best example. It's very challenging, this topic, to figure out like where the line is. But it's like, is it trying to do more than one thing conceptually? If I was to explain this to someone and they're like, what does it do? Can I be like, it does this, without using the word and, also, or anything like that? Just does this. And if it doesn't just do this, it probably does a few things. And if it does a few things, break it up into more components. That's really all this single responsibility principle is about. There's not much to it. It's a lot more applicable to classes, for instance, which is probably why I've gotten rid of this example. Without realizing. But it can be applied to functions too, because sometimes we write functions that do many things without realizing. So they're two takeaways from today, is go have a look at your code and think about any instances where you can use decorators, and have a think about any instances where you might be able to break up your functions into more pieces. So that's pretty much all we have for today. I don't think it was point, but that's okay. I'm pretty sure it was a class example, so I wouldn't have been too thrilled on it anyway. Yeah, that's all for software engineering design principles 2.